Good day, everyone. I'm Ronald, the moderator for this webinar. I welcome everybody to today's webinar that is on artificial intelligence, AI in the food supply chain. I want to introduce our presenter for today, that is Dr. John M. Ryan. Dr. John Ryan is the president of RyanSystems.com and holds a PhD in research and statistical methods. For more than 25 years, he has implemented quality control systems for international corporations in the United States and worldwide. I would now like to hand over the floor to the speaker. Over to you, John.
Let me start again. I'm going to spend a little time with you today talking about artificial intelligence, and I'm going to pick it from the ground up and then apply it to food supplies chain and a few other areas. A few of the things you might have heard about, AI video generators, logo generators, chat box writers. So it's being applied in a lot of areas. So what is quantum AI now? It's an emerging field of computer science that applies the transformative power of the quantum computing to the research and development or improved artificial intelligence products, such as machine learning algorithms, neural networks, and large language models. Okay, a couple of perspective. It's a new approach to food safety. Okay, 3 laws of robotics from Isaac Asimov. It may not injure a human being or through inaction allow a human being to come to harm. It must obey orders given to it by human beings, except where such orders would conflict with the first law. Okay, so in other words, there's ethics involved theoretically in the field of robotics, which AI is heavily involved in. A robot must protect its own existence as long as such protection does not conflict with the first or second laws. Okay, some predictions. Artificial intelligence can read every article that has ever been written on a topic, come up with novel ideas, design experiments, conduct the experiments, and use breakthrough results to solve problems in far less time than humans can imagine. So the questions become, what computational principles make intelligence happy? Can we use these principles into a computer to establish its ability to learn? Will accelerate. People will come up with programming solutions and databases that help accelerate the ability of these computers or robots, whatever they end up being, to actually learn and create solutions. Quantum computers or supercomputers, they're employing, the path is through analytics and algorithms. I'll talk more about those. Massive databases, I'm going to talk about that a lot. Deep learning, human level artificial intelligence. And you know what CAPTCHA is, you've been online. Automating human ingenuity. What AI is about is developing robots that can handle uncertainty and computers that invent computers. Now, okay, so here's a biggie one that we can't handle very well. Climate change could make food less safe. Okay, food contaminated with bacteria, viruses, parasites, toxins, or chemicals causes more than 600 million people to fall ill every year. So artificial intelligence is being applied by some of these companies I talked about, where it's having a massive impact in the world today. AI will transform almost every industry in the next several years. Okay, and here's one of the issues that when it comes to food and food safety and food security is this right here. The global population is expected to rise to 9.7 billion in the next, 25 years. And so AI is seen as a means to feeding this population and keeping it safe. Okay, there's a concept here. Precision agriculture is an approach to farm management that uses information technology to certify that crops and soil receive exactly what they need for optimum health and productivity. This is a good way for PA to, help us preserve our crops and soil. Automated analysis from the roots up. Soil testing, temperature, humidity monitoring, rainfall measurement, bacteria pathogen sensing, mold detection. That's a biggie. Weed monitoring and elimination. This would reduce that. Pest detection, leak detection, leaf health, location, size of stalks, leaves, produce. So all of this impacts the water, fertilizer, pesticides, fuel, and labor reduction. Sustainability issues, pollution reduction, water quality improvement, optimizing inputs to reduce wasted fertilizers and pesticides. It identifies potential defects and nutrient deficiencies in plants and soil. Users are then provided with soil restoration techniques, tips, and other potential solutions with a 95% accuracy. Software algorithms. In math and computer science, an algorithm is an unambiguous specification of how to solve a class of problems. They can perform calculations, data processing, automated reasoning, and other tasks. Location intelligence, enabled by modern geographic information systems, GIS technology, magnified by machine learning automation, and done at scale in real time for retail, finance, and different industries. The location intelligence, where are you? Where are all these things? Okay, so machine learning is a method of data analysis that automates analytical model building. There's a branch of AI based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Where does the data from machine learning come from? Big data. Then there's other techie companies that are involved with these guys to develop for them the types of software that AI needs. Deep learning software learns to recognize patterns in digital representations of sounds, images, text, and other data. They don't just learn, now they can create. It's an acronym for completely automated public Turing test to tell computers and humans apart. It's a type of challenge response test used in computing to determine whether or not the user is human. Any program that passes the test generated by CAPTCHA can be used to solve a hard, unsolved AI problems. Then there's other things like MongoDB, making sense of unorganized data. Okay, Gopher protocol, a wireless network that connects many gadgets on the internet of things. Everything talks to everything else. Its Gopher protocol will be able to track anything, reducing thefts and lost items. Touch on blockchain a little bit. It creates a shared ledger based on smart contracts through the supply chain. So where we're trapped today is individual ledgers. Ledgers are a source of errors, fraud, lack of detail, order payment account tracking problems. Blockchain creates a set of digitized smart contracts that must be fulfilled at each supply chain transition point. So there's part of AI called Hyperledger Composer. Everybody can talk to each other because they're standardized. They have pluggable architecture. So this is a backbone for creating massive databases based on finance, money, okay? Terms and conditions of the sales. What's the contract? How much do I ship? How much do you pay me per shipment? Where's the traceability data? Where's the temperature control data? Payments, commissions, and fees, all part of the smart contract. Speed and accuracy. When is it done? How fast is it done? Scouting, measurement, and detection without human intervention. Identify potential defects and nutrient deficiencies in plants and soil. Image capture and recognition. Smartphone app that also provides information regarding soil restoration techniques and being picked up maybe by drone guidance systems. Here's a cloud level system. Here come the drones. The sensor data goes into the drone, then it goes into the cloud. So now that data is through the Internet of Things automatically being collected from the farm level and transmitted through the internet to the farmer's cell phone or maybe even the supermarket cell phone. Self-driving tractors, look at that beast. Harvesters, same thing, being controlled by the internet. Sorters, self-driving trucks. Inventory problems could be solved with robotics. Improved time to market control. Improved routing, first in, first out distribution. Sensors and delivery processes. Contaminant discharges. Food safety, our concern is with preventing risk to human health through the entire food supply chain. And how many places could the ball get dropped? Maybe this reefer didn't work on this truck before it's bought and taken home and cooked. We got this food safety system. It's got different kinds of costs for inspections, audits, training, documentation. You've been paying for them for years now, right? Reporting, recalls, sampling, multiple consumer audits. Under the preventive control rules, current good manufacturing practices, GAP, international adulteration, transportation. And this is what we're after, hazardous adulteration, bacteria, chemical, physical adulteration, food residues. Where could that occur? Everywhere. International, economically motivated, chemical extraction and migration, allergens, that's a big one everybody knows about. Global food hazards, environmental sampling. Okay, this we do all the time. AI collects and analyzes samples, product oil, soil, potential to stop escapes and react quickly to escapes. Okay, primary blockchain concept is shared ledger, a system of records, an unalterable record of all transactions on the network that all network participants can access and view. Participants are allowed to see allowed through permission and can control what they allow others to see. And that's based, all this stuff is controlled by your pricing, delivery, and quality. Okay, so we get to, okay, I got all this statistical data. AI uses data and statistical analysis to predict. So that's electronic traceability, food safety certification, biological contaminant that you test for, water contaminant, chemical contaminants on the produce, and chemical contaminants in the water, transportation controls, are less likely or at a lower risk to cause illness and death than those not employing such generic food safety practices. It's going to look at traceability, supplier compliance, risk, and recall controls in this one crummy quantum computer among this giant network of people all depending on each other, these packers and retailers, farms, processors, distributors, etc., restaurants. That's my last slide. That's the scary part that you're all facing. Okay, that's it for me today. I hope you got a picture of where we're going, where we've been.
Thank you, John.
All right, so we went through a lot of stuff. I showed you the evolution of, I think, basic data that you hold in your company through what's coming at you. All right, well, thanks for attending. Don't let artificial intelligence scare you like that picture. Hopefully it never gets to that level. All right, once again, thanks for attending, folks. See you again.
Yes, John, we all hope that it does not go that way. And once again, thank you, John. And that concludes the session for today. Thank you everyone for participating. You may all disconnect now. Have a great day ahead. Thank you. Bye-bye.